started the recording, and let me also share the screen with you guys. I was asking because here there are not a lot of people, like there are 9, 9 and 8, 17 people only. Ideally, you guys should be somewhere around 37, 38. So we are half the strength. Sorry. So kindly communicate to others that we are meeting here in this meeting. Okay, so let me share the screen with you. Okay. Can you guys see the screen?
Sir, there are like 2 meetings right now. They have created another one.
Okay, so what should we do? Let us all then try to join the other one, the regular scheduled one. Okay, it was not given me an option, so I think I got confused. So either they can come here. How many are we right here? Like 9, 18, 19, 20, 22 are here. So I think most of us are here. So if any of you can message them to disconnect from that meeting and connect here, that would be good, because most of us are here and it's easier for less number of people to change than most of us. Okay, kindly message them to announce on the chat of that meeting to disconnect from that meeting and join the meeting in general channel here that we are currently in now. Let us wait for a couple of minutes to see if other people come and join. Okay, the attendance has improved a little. We are around 28. So about 10 more people, 9 or 10 more people who are still missing. Let's wait for a couple of minutes. Kindly message other people who are on the other chat to leave that meeting and join this one here. Okay, numbers are not improving. We are still, in fact, we have become 27 from 28. So, did you guys message the others? I mean, are you guys in contact on WhatsApp or whatever?
Yes, sir. I have informed all of them, but sorry, Alishba
Okay.
has.
Okay, thank you. And let us wait for a couple of more minutes. And meanwhile, we can discuss. Have you guys tried that dividing your program into multiple files and then compiling those multiple files to make one exe and run it? Okay, nobody has tried it? Okay, that is sad, but okay. So there was a question, is it necessary to use recursion on the assignment? Yes, if you're talking about assignment number 3, it is necessary to use recursion in every question. Otherwise, I mean, there's no point, there's not also no point, but also like you are specifically given the task, for example, in that GCD function, greatest common divisor, you are told to find GCD by first by Euclid's method and then by Dijkstra's method. Okay. So if you are not using those methods, you are like missing the point of the assignment. And secondly, the third question about Towers of Hanoi, it is, I think it will be very difficult to do it without recursion. Okay, it's much easier to do with recursion than trying to do it without recursion. Okay, so this assignment is basically practice for recursion for you guys. So meanwhile, while we wait for some other people, do you guys have any other questions about the assignment? And yesterday there were questions about the assignment that I was not able to take. So while we are waiting, we can talk about the assignment if you guys like. Yes, Uzair, do you want to say something?
Yes, sir. The final exams questions will be always also like this, means which you are giving in the assignment. This seems very difficult, means to do it within a short range of time.
No, the final exam, it will be limited time, so questions will be, of course, easier than this.
Okay, sir. Thank you.
Okay, so any question about the assignment number 3? Alishba, I think you had a question. Is it still there or is it like solved? Can you explain the description of the assignment? Okay. In question 2, for GCD AB, we have to return A minus B, B. No, it's not you have to return A minus B, B. You have to return the GCD ultimately. Greatest common divisor, which will be one number. Okay. So about this return A minus B and B, it's not returning A minus B, B. You should call GCD again on A minus B, comma B. Okay, so GCD, as you know, is a recursive function. I mean, the way that you have been asked to do it, it's in a recursive way. So GCD, if certain conditions are fulfilled, then you have to call the function GCD again. It will call itself again on A minus B, comma B. Okay, the value returned ultimately will be one number, which will be the GCD, like the greatest common divisor. Okay. Can you explain a description of the assignment? What do you mean by the description of the assignment? Yeah, we'll continue about yesterday's lecture, but we are waiting for your fellow students to join. So meanwhile, if you have questions about the assignment, you can ask them. What do you mean by the description of the assignment? Description of question 3. Yeah, so question 3 is basically, it's called the Tower of Hanoi problem. Let me see if I can find a graphic on Google. Give me a minute. Just give me a minute. I'm trying to find a suitable descriptive graphic. Oh yes, very good, Asher. If you have found the game, then it's a very good way to know how does it work. Okay, so I will basically give you the problem explanation in recursive terms. Okay, once you formulate the problem recursively, hopefully it will be easy for you. So can you guys see this image? Okay, good. So let me explain this to you. Oops. So you guys have this n disk. Okay, n could be any number. Okay, and you have like 3 towers. Okay, so usually one tower is the source tower, and one tower is the destination tower, and one tower is this auxiliary or intermediate tower where you will place your disks temporarily while you transfer them to the destination. Okay, so one rule of Tower of Hanoi is that no bigger disk can be put on top of a smaller disk. Okay? A smaller disk should always be on top of a bigger disk. Okay, you can't put a disk on another disk such that the lower one is smaller. Okay, so this is one rule that you have to preserve in all your steps. So you have like n disks, n could be any number, and those n disks you have to transfer them from source to destination while respecting this rule of no disk can be on top of a smaller disk. Okay, so we have to transfer it from source to destination. Okay, and you can transfer only one disk at a time. So whenever you have a problem, if you think that it can be solved by recursion, then you have to first formulate the problem in a recursive manner. Okay, so transferring n disks basically would amount to, let's say we have this transfer function. Okay, transferring n disk. Transferring n disks from source to destination is equal to first transfer n minus 1 disks from source to intermediate, okay, and then we transfer the last disk, because once we have the n minus 1 disk on the intermediate tower, then we have only the last disk left on the source tower. Last disk is the biggest disk, so biggest disk we can basically transfer this from the source to destination directly, okay, without any fear. We can transfer one disk at a time. We have this one disk on the source, we transfer it to destination without any fear, and then we basically transfer the n minus 1 disk from auxiliary to the destination tower. Okay, so this is the recursive definition of towers of Hanoi. Why? How is it recursive? Because to transfer n disks, first we have to transfer n minus 1 disks to auxiliary, okay, and then we transfer the last disk to destination, and then we transfer n minus 1 disks from auxiliary to destination. Okay, so when transferring n disks, we are basically first transferring n minus 1 disks from source to auxiliary, and then after transferring the last disk, we'll transfer n minus 1 disk again to auxiliary to destination. Okay, so this is the recursive formulation of towers of Hanoi. So did you guys get it? Like page 90. I hope it doesn't give you the solution in the DS Malik book. So the idea is that to transfer n disks, you have to first transfer n minus 1 disks. Okay, so this is like the recursive definition. Towers of Hanoi for n disks will first call towers of Hanoi for n minus 1 disks. And similarly, towers of Hanoi for n minus 1 disks would first call towers of Hanoi for n minus 2 disks. Okay, so this similarly it will go on recursively until you reach the terminating condition. Okay, and what's the terminating condition in this case? In towers of Hanoi, what's the most trivial case that we can have? How many disks can we transfer without any like worry or without any recursion, without anything to worry about? What will be the terminating condition for towers of Hanoi? N is equal to 1. Very good. Okay, when there is only one disk, then we don't have to worry about anything, and we just transfer one disk from source to destination. Okay, but when we have more than one disks, then to transfer n disks, first we transfer n minus 1 disk from source to auxiliary, then we transfer the last disk from source to destination, and then after transferring the last disk, we transfer the n minus 1 disks that were on the auxiliary. We move them again and transfer them from auxiliary to destination. Okay, so in transferring n disks, we will basically call Tower of Hanoi on n minus 1 disks twice. First to transfer those n minus 1 disks from source to auxiliary, and then once we have transferred our last disk, we will call Towers of Hanoi again on n minus 1 disks to transfer those n minus 1 disks from auxiliary to destination. Okay, is the description clear? I mean, is it better now? You are not giving any response. Who asked a question? Alishba, is it clear now? Is it better or not? Okay, to others, is it clearer now? N can, yeah, the number of disks, which is n, it can be any number, and the number of towers always remains 3. Yes. Okay, number of towers is always 3, and disks, you can have any number of disks from 1 to n can be any number. Okay, but as you will see in later courses, if n becomes large, it can take some time, this problem. You guys should solve for like starting from n is equal to 1, the trivial case, you should go for like 2, 3, 5. Okay, not very big numbers, but at least verify your program on small numbers. Okay, that it works correctly. Any other question regarding the assignment? Do we have to do it? I'm afraid yes. Yes, you can also, I mean, just try calculating the time till the end of the universe. Well, it's just that the legend says that there are 64 disks that they are trying to transfer. Okay, so if they are trying to transfer 64 disks, then try guessing how much time would they take transferring all 64 disks. You can assume any time, like you can assume that they are transferring one disk in 1 second. Okay, if they transfer one disk in 1 second, how much time it would take to transfer 64 disks? Okay, because after 64 disks, the world would end, according to the legend. What's the assignment weightage? Assignment weightage is collectively like 15% for 3 assignments. Okay, so it's 5% for each assignment. I think that's what's written in the syllabus. Yeah, you can read the Wikipedia article. It tells you how much time it would take. Yes, Uzair, do you want to say something?
Yes, sir. Sir, could you explain the file format for the assignment? Means, is there any separate file for main or function?
Yeah, you have to find like 3 files. One file would contain your main. 3 CPU files. Okay, one file would contain your main. One file would contain the do function for the GCD, and one file would contain the function for Towers of Hanoi. Okay, these are 3 CPU files that you are going to submit, and then there will be one .h file which will contain the headers of all these functions, the 3 functions that we have you have developed. That file will contain the prototypes for those functions.
Sir, the main functions of all of the 3 questions?
No, not main function. The main function means the function whose name is main. Remember, in every C++ function, in every C++ program,
Sir.
there is a function called main. So the main file should contain only the main function.
Yes, sir, I know that, but for every function there is a main function. So I mean that for every three questions.
Not for
we
every
will
function.
get
Not
one.
for every function there is a main function. For
Every
every
question, sir. For every question, sir. Sir, for every
no, for
question
every
there is a
program.
main.
For every program there is a main function. So you guys can have one program which have all these three functions and only one main function.
Okay, sir.
I mean, did it become clear or not?
Yes, sir. It's clear now.
Okay, good. GCD, CPP will contain they will contain a definition of the functions GCD and towers of Hanoi. Should we submit those four file in zip file? Okay, if you can submit it individually, submit them separately. If you want to submit a zip file, you can also submit a zip file. But in that case, name the zip file with your registration number. .h file will contain only the headers of all the functions. How we separate these files in Dev C++? I told you yesterday you can create new files in your project in Dev C++ and give them names and write code in those new files. They will automatically be added in your project and it will be compiled by your compiler. So you should add these new files in your project in Dev C++. Okay, you can try Googling this stuff, how we can add new files to the project in Dev C++. Sir, can you write this down in an email we can remember? But everything is written in the assignment description. There's nothing new that I have told. Just read the description again and it would become clear. It's written that some functions should contain definition of functions. Some files should contain definition of functions. One file should contain the headers of all functions. That's all. Okay, is it clear about the assignment? Okay, so let us move to the example that we were studying in our last class. In .h file, we don't need to write using namespace or hash include, right? Just the prototype. Yeah, .h file should just contain the prototypes. Yesterday's lecture and tomorrow's lecture are about this. Yesterday, today, and tomorrow are about this thing, how you can separate your program and use multiple files to make a program. Okay, so we were so here is our main file in which we have the main function. Okay, so you guys also will have one file which will contain the main function. Okay, so I'll correct this path. And then we have other file called multitude.cpp in which I have this definition of Fibonacci function. Okay, so you guys will have two extra .cpp files. One will contain the definition of GCD functions and one would contain the definition of towers of Hanoi function. Okay, and then you guys will have one .h file which will contain the declarations for all your functions, just like I have this .h file which contains a declaration for this fib function. Okay, and if I go to this main file, we can see that I have included this .h file in my main CPP file because I am calling this function fib here on this line number 13 to 16. Okay, and before calling any function, we have to declare it in our program. Okay, so here I have basically included this file multi2.h, and as we discussed yesterday, the hash include directive or the hash include command to the preprocessor does nothing but ask the processor to copy the ask the preprocessor to copy the contents of this file at this place in this file. Okay, so let me see. Let me show you how does the processor does it, preprocessor does it. So I'll comment it here. Just multi2 starts here. Multi2.h starts here. Okay, so let us see. There is this command which will give me the output of the preprocessor. Multi1.cpp. Okay, so this is, we'll store it in a file. Multi1 preprocessor. Okay. So if I open this file, you see all these hashes. This is the output of preprocessor. I have asked my preprocessor to process the multi1.cpp file. Okay. So the first line in multi1.cpp says hash include IOStream. Okay. So all this stuff that you are saying, this is the content of the file IOStream. Okay, it is all copied here, and as you can see, I am scrolling down. Let me go page down because it can be a long file. We are still at like 2%, 4% of the file. Okay, so let me go to the end. You see, this is my main function, and here is my int fib. You see, multi2.h, it starts here. Okay, and here is the content of multi2.h that are pasted. Before this, using namespace std, this was also in our file, main file. But before this, until line 18,155, all this 18,000 lines, this is the code for IOStream. Okay, so the preprocessor has basically included all this code in your file. And why do we? Okay, but I will come to it later. So then there's this line using namespace std. This is as it is. And then after using namespace std, we had included hash include multi2.h. Okay, so here it is. The preprocessor has copied the contents of multi2.h and it has pasted it here. Okay, and now our compiler, then there's our main program. Okay, so this is the output of the preprocessor and it will be given to our compiler. Okay? So our compiler, when it checks this file, it starts from the beginning and comes down checking everything. It will go through this line 18,163 carrying the declaration of the function fib, and it will basically arrive inside main. Okay? Inside main, we are calling fib multiple times. So here, when the compiler comes here, it will see the call to main, call to fib, and it already knows what is fib. Okay, because by the time it arrives here, it has already seen declaration for fib, and it knows that fib is a function. Okay, so fib basically it says okay, fib is a function, and it compiles this file. It compiles this file. Similarly, we give other files also to our compiler. It will compile all the other files. So this file will contain the code for main, etc., and other file will contain the code for fib. Ultimately, the linker will basically make the connection between this code, this function call, and the body of the function. Okay, so the linker will say that whenever this function is called, the program execution should jump to the body or the definition of the function fib, which is in that other file. Okay, so the linker will basically link this call to the function code or the body of the function. Okay, so that's why we call it a linker. It will link all the different components of your program and basically combine them to make one executable, which will then run as your program. Okay, is it clear? The output of the preprocessor and what does the hash include command does? Let me see your comments. There is no need for hash unit gc.cpp and ty.cpp. Acha, hash include basically you should understand the purpose of why we are including something. Okay, and then you will know where you need to include something and where you need to where do you not need to include something. Okay. So what is the purpose of include? So hash include multi2.h, we saw we need to include it to have the declaration before the call to the function. Okay, so that's why we are using hash include multi2.h. Okay, so we need it in main. Do we need it in fib.cpp? Or sorry, what's it called? Multi2.cpp? No, why? Because we are not calling fib in multi2.cpp. Okay, so that's why we will not need hash include multi2.h. Okay, is it too clear? Is it clear to everybody else also? Hello, other people. Do you guys know why we are including hash include multi2.h in main file, and why do we not need hash include multi2.h in the second file multi2.cpp? Come on, other people. Yes, to you it is clear, but I am talking about the other people. Okay, second, what do you mean by maybe? I'm asking about how do we know, I mean, why do we need to include? The original question of Mohammad Fareh was, do we need to include, use hash include in other files or not? Okay, so I said for that we need to know first what is hash include, what does it do, and why are we using hash include with multiple files in main. Okay, so let's take the case of hash include multi2.h. Why do we need to include hash include multi2.h in what's it called, in the main file? Let me open the code of the main file for you guys so that it is easier. Multi1.cp. On line number 5, we are doing hash include multi2.h. Why do we need to write this line hash include multi2.h? To include the code of that file. Yes, include always include the code of the file, but what is this code and why do we need to include the code of this file in this main file? What is in this file that is so important that we need to include it here? Yes, so it contains a declaration of this function, and we need this declaration because we are calling this function, okay? And before calling any function, we need to have its declaration in the code, okay? Otherwise, we can't call fib. It will give us an error like we saw in our last class. Okay? So in main, we are calling fib. That's why we need to have the declaration of this function fib before main in this file, okay? And this declaration is contained in file multi2.h. That's why we need to include multi2.h in this file. Okay, is this clear? Okay. I hope it is clear to others also. About sending these codes, you can talk these things also at the end of the class. Right now, it would be good if you answer the questions that I am asking. Wait, Muhammad Fareh, ask this question again after a couple of minutes after I finish this explanation. So, okay. Okay, so I hope it's clear to everybody that we need to include multi2.h here in this file, and why do we need to include it? Do we need to include multi2.h in the second file? Let me open the code of second file. Do we need to include multi2.h here in this second file? Yes, why? Why would we need to include multi2.h in this second file? Saleh, why do you think multi2.h should be included in this file? What does multi2.h contain? Okay, no response. So those who are saying no, can you please explain for the benefit of your fellows why we do not need to include multi2.h in this file? The function header serves as a declaration, which is already included. Okay, or the function definition also can serve as the declaration, okay? Definition basically serves as both definition as well as the declaration. And also we are not calling fib here. Okay? Since we are not calling fib here, we do not know, we do not need the declaration of fib in this file. Is it clear to everybody? Hello, these silences are very, very awkward. Okay, good. So we don't need this file here, include this file here. Okay, so the other question is, if I have, why do I need to include IOStream in this file, in the main file? Very good. Because we are using cout. IOStream, as you can guess from the name, contains all the declarations related to IO. Okay. Whenever you need to do IO, then you will need to include IO streams. Okay. IO means input and output, and here we are using cout. Okay. So whenever you use cout, you are doing IO, and whenever you use cin, you are doing IO. Okay. So whenever you use either of these, cout and cin, you have to first include the declarations of these functions and all the stuff related to IO. So that's why we need to include IO stream in this main file. Okay. So if I remove this, what's it called, cout lines from this main, I will not need to include IO stream in this program. Okay. Is it clear? Why do we need to include IO stream in this file? And IO stream code, as you guys saw in the output of the preprocessor, it had lots of code. Okay, it had thousands of lines of code. Okay? That is all included in our program because cout needs all those declarations to work. Okay, so if this is clear, then what was I getting to? So do I need to include IO stream in the other file? Let me open the other file. Do I need to include IO stream in this file?
No, sir,
Why?
because we are not using any chain or cout command in this function.
Very good. We are not using any scene cout command in this function. That is why we do not need to include IO stream in this file. Okay. Good. So, okay. So I hope now you guys are clear about when we need to include something and when we do not need to include something. Okay. So hash include is basically to include the declarations that we need in any file. Okay. So these declarations, they can come from system files or they can come from your files. Okay. So we have both of these here in this file. Let me open it again. So line number 1 is including declarations from a system file, IOStream, and line number 5 is including declarations from our file, multi2.h. Okay, so you will include this declaration on a need basis. Whenever you need something, you will include its declaration in your file. Is it clear? Yes, Ozair, you want to say something?
Sir, if we call multi2.h inside the syntax of the multi2.h, so will it be a kind of recursion?
Yes. If you call multi2.h in this multi2.h, let me copy this line and we go to this file multi2.h and I put it here. Okay, so we include multi2.h in main, which itself includes multi2.h, which is the same content, so which will itself include multi2.h. So this is like a recursion. And as you guys can guess, what will happen in this case? We didn't hear you.
I think, sir,
The signal is very distorted. We can't hear you. It's like a radio in a storm. But we'll just try to compile it and see what happens in real time. Okay, so this is the command that we were giving, and as you can see, it's a recursion, and it is ultimately kind of an infinite recursion. So your computer detects it and it gives you an error, hash include nested too deeply. Okay, so in each .h is including another .h, and same .h is including another .h, etc., etc. So it's a recursion without any terminating condition. So it is an infinite recursion. Okay, so that's why we will remove it from here. Okay. So there is a solution to this, and we'll study this solution in the next class because right now our time is up. So if you guys have any questions so far, you can ask them. We didn't do much in this class. But okay, so again, save this question for the next class. Why did I use double quotes instead of angular brackets in line 5? Okay. So right now that we'll take up this question, but the thing is that class time is up and some people might need to leave. Wait a minute. Let me first see the questions before we take. Where can we read on this topic? You can Google like including files in header files in C++, okay, including declarations in C++, or splitting your program in multiple files in C++. Okay, if you type this kind of phrases on Google, you will find many articles that address this issue. Okay, so so I'll stop here and we will continue Thursday. Okay, so meanwhile try this thing, and if you face any problems, come with questions to Thursday class. We didn't do much here, but okay, at least you guys learned a couple of things at least. So there were some things that I wanted to talk about, and we'll do it on Thursday's class. Okay, I'll stop the recording. Thank you very much, and see you guys on